Today we are learning the graph of y is equals to 2 to the power x. So this equation represents the number of folds of a paper. Okay, how each time you fold the paper the number of regions doubles. Now you have a paper, so if you fold this paper one time you got two regions. Okay, and you fold it two times you got four regions. How? That's 2 to the power 1 is equals to 2. If we fold one time, if we fold two times, we got 2 to the power 2, which is equals to 4. So we got 4 folds. And now they are asking copy and complete the table, discuss any pattern you see, right? If number of fold is 1, we got 2 regions, and if number of fold is 2, we got 4 regions. For 3 we got 8, and so on. So the pattern is 2 to the power x. Okay, so now in B part, is the relationship between the number of regions and the number of folds quadratic? Explain. No, this one is not quadratic, because quadratic equations we have y is equals to x square, in which the power is 2. That one is called quadratic relations. Okay, so this one is not quadratic. For C part, we are going to draw a table of x and y values, and we will do this later. Before D and E part, we will do this F part, because here they have given the data in which they are saying that we have to start the value from -5, and every time we do a increment of 1, and we find the values of y is equals to x square and as well as y is equals to 2 to the power x. So for F part, I have drawn a table which is starting from -5, and every time we will do an increment of 1. How? If -5 plus 1 is equals to -4, and the next step is -4 plus 1 is equals to -3. Now first we will do for y is equals to x square. Now if I substituted x is equals to -5, so y is equals to -5 square. We know if the power is even, the negative will become positive. Like here the power is 2, so the negative will convert it into positive, and we have to write the 5 square, which is 25. Same, x is equals to -4, y is equals to -4 square, which is 16. So our coordinates of this graph is -5 and 25. Same for this -4 and 16. So for x is equals to -5, we get the value of y is equals to 25. For this one is 16, for this one 9, 4, 1, 0, and for 1, 4, 9, 16, 25. Okay, so now we will do this same for y is equals to 2 to the power x, in which we substitute x is equals to -5, and we found the value of y, which is 2 to the power x, which is y is equals to 2 to the power -5. Now we will learn a concept here, which is if a to the power m and a to the power m. Here the bases are same, which is a, right? And the powers are m and n. So if the bases are same, the powers will going to be add. Here a to the power m into a to the power n is equals to a to the power m plus n. Okay, and for this one, if a to the power m over a to the power n, here a to the power n is in denominator, here a to the power n is in multiplication. You have to remember this. Okay, now if a to the power n is in denominator, then we have to write, and bases are same, so we can write a to the power m minus 1. So these are the formulas that you have to remember. Okay, remember these formulas. These are important formulas for your unit test. Okay, so now if 1 over a to the power n is there, then we can write a to the power minus n, as well as if a to the power minus n is there, then we can write 1 over a to the power n. Okay, we are writing 2 to the power minus 5, which is y is equal to 1 over 2 to the power 5. 1 over 2 to the power 5 means 1 over 32. Okay, so in fraction I am writing this value in fraction 0.03125. Okay, but here I am writing 1 over 32, here 1 over 16, here 1 over 8, here 1 over 4. If we have any value a which has the power 0, then every value which has the power 0 we always get 1. How? If 1296 to power 0 is given, then this value is 1. Okay, You have to remember this. If any value which has the power 0, we got the answer 1. Okay. So now for this one, we have to write 1. Now y is equals to 2 to the power x, in which we are writing 2 to the power 1, which is equals to 2. So here 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8, 2 to the power 4 is 16, and 32. Now if the here the power is negative, that's why we get this on denominator like 1 over 32. But here the power is positive, 2 to the power 5, which is we are writing 2 times 5. Okay, so which is 32. 2 to the power 5 is 32. Okay, so we got 32 in numerator, and here 32 is in denominator. Okay, now we know how to draw this graph. These are all the coordinates of parabola, or not parabola, y is equals to 2 to the power x. So this graph will go like this. I am drawing a rough diagram. Okay, so it's not going to meet on x-axis. I will show you how, but check up to this. Okay, so this one is the graph of y is equals to 2 to the power x, and we know the graph of y is equals to x square, which is parabola, which will look like this. Okay, and now we have to write the difference between these two graphs. Okay, so let's check on Desmos. So yeah, this one is the graph of y is equals to 2 to the power x. Okay, in which this graph will look like this, which is going through the x-axis. But if we zoom this graph is never going to meet on the x-axis. Okay, check it. Check. So this graph is never going to meet. So there is not any intercept on this x-axis of the graph. Okay, so yeah. And now for D and E part, we just have to compare the graph of y is equals to x square and y is equals to 2 to the power x, as we learned in F part. Okay, but the difference is given in your notebook, in which they have drawn the graph of y is equals to x square, y is equals to 2 to the power x. Now as I shown you the y is equals to 2 to the power x graph, okay, the graph has no x intercept and a y intercept of 1. So here this graph going through y axis, okay, which is the intercept of y axis, and which one is 0 comma 1. So this one is the coordinate of the y intercept of y is equals to 2 to the power x graph. So here the intercept of y axis is 1. Okay, and the y value increases as x increases, as we done in this F part. The y value increases as the x increases. Here the x is in negative, but we got y value is positive. Same up to negative 1, and for 0, which is 1, because we know 1 over 2 here. For x is equals to negative 1, we got the y is equals to 1 over 2, which is 0.5. Okay, and now we are increasing x value. The y value is increasing. For 1 we got y value 2, for 2 we got y value 4, as this. But not same for x square. For parabola, I mean for y is equals to x square, if we increase x from negative 5 to negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, we are going from negative 5 to positive 5. Okay, so here y value first is at highest, I mean for negative 5, which is 25, and now we are decreasing up to 0, and then we are increasing up to 25. Okay, so as y value increases, x increases. Okay, and for parabola, for y is equals to x square, the y value decreases and then increases as x increases. Okay, so that's how we define the parabola. Now as x increases in the positive direction, the y value increases much faster than the y values for y is equals to x square, as we seen in the table. As x increases in the negative direction, y value decreases towards 0. So this line is important. How they are saying that x is increases in the negative direction, the y value decreases towards 0. So now we will learn up to y is equals to 2 to the power minus 5, which is 1 over 2 to the power 5, right? So now which is 1 over 32. Okay, now they are saying that the y is increasing, which is 0.03125. Okay, Now if you took y is equal to 1 over 2 to the power minus 10, just 2 to the power minus 10, which is 1 over 2 to the power 10, which is 1 over 1024, which is 0.00 something, 0.00 something. Okay, 0.009765. Okay, value is never going to be 0. Okay, it's always towards the 0 but not 0. Okay, so now these are the comparisons of a parabola and y equals to 2 to the power x graph. Okay, you can write it from here, and this comparison is available in your book also. And now we will move towards g part, in which find these there what are the values of these given values. Okay, so we know 2 to the power 0, 2 to the power 0, anything power 0 is always 1, and 2 to the power negative 1 is, here the power is in negative, so we write it in denominator 1 over 2, which is 0.5. Now 2 to the power negative 2 is 1 over 2 to the power 2, which is 1 over 4 and 0.25, as well as for 2 to the power minus 3, which is 1 over 2 to the power 3, or 1 over 2 to the power 8. Okay, you can write their values, because we have to write these values in rational form. Okay, now for h part, express each decimal for part g as a fraction. Rewrite each fraction by changing the denominator to a power 2. We learn this part in g part, so there is no need to do. Now same for this I part. Okay, based on your answer for g and h part, make conjectures about these values. Okay, so now here we have to find the values of 3 to the power 0, 5 to the power 0, find the values of 3 to the power 0, negative 1, negative 2, negative 3. Okay, write these in rational or fraction form. Okay, same for 5, do it yourself. Now for j part, summarize the difference between y equals to 3 to the power x and y equals to 5 to the power x by using their graph to determine these values. Okay, now so we have to find these values. First you have to draw the table of y equals to 3 to the power x, as we draw for y equals to 2 to the power x, and same for y equals to 5 to the power x. But there is no need to take much values, just take negative 3, negative 2, negative 1 to 0, 1, 2, 3. Okay, these are enough to draw a graph. So now in j part, they are asking the difference between y equals to 3 to the power x and y equals to 5 to the power x by using their graph to determine. Okay, so you have to make the tables of y equals to 3 to the power x and y equals to 5 to the power x, and make a table and draw that graph. I just directly draw this graph on Desmos, in which the red line shows the y equals to 5 to the power x and the blue line shows the y equals to 5 to the power x. Okay, in which the y is equals to 5 to the power x graph is more steeper than y is equals to 3 to the power x of their symmetry. So yeah, y is equals to 3 to the power x, y is equals to 3 to the power x, as well as y is equals to 5 to the power x, they both are not symmetric. Okay, and there is not any x-intercept for both of these graphs, because we know for y equals to 2 to the power x, if we go towards the negative axis, which is 1 over 2 or 1 over 2 to the power 2 or 1 over 2 to the power 3, we are just going towards 0, but we never gonna met at 0. Okay, so there is always towards 0, so there is not any x-intercept. And for y-intercept, we just have to substitute the value of x is equals to 0, so we get the y-intercept. Y is equals to 3 to the power 0, which is 1, as well as y is equals to 5 to the power 0, which is 1. So their y-intercept is going to be same, which is 1. Okay, when the y values are increasing. So yeah, for all values of x, the y values are increasing, and when the y values are decreasing, never. y value is never going to decrease. Okay, what happened to the y values as x gets larger in the positive direction? For y is equals to 3 to the power x, if we increasing the value of x, y value is going to be increase rapidly. Y increases rapidly. Okay, and because we are going in the positive direction, and for y is equals to 5 to the power x, y grows even faster. Y grows even faster. Okay, because of their values, which is 3 and 5. And what happen when the y values to the y values as x get larger in the negative direction? Now if we move towards negative x, and they are asking about what is the effect on the y axis, on the y values, sorry, y values, they both are going to approach, they both approaches to 0. Okay, approach to 0 but never going to be 0. So your answer for this part is they both approaches to 0. Okay, now we do k part. Will the graph of y equals to 2 to the power x ever touch the x-axis? Explain. Not. Y is equals to 2 to the power x graph never touches x. Never touch x-axis, because if we move towards negative x-axis, now you just have to write the values like x is equals to -1, -2, -3, -4. So write it like this: y is equal to 2 to the power -1, 2 to the power -2, 2 to the power -3. Okay, so y is equal to 1 over 2, 1 over 2 to the power 2, 1 over 2 to the power 3. Y is equal to 0.5, 0.25 and so on. So at some of bigger values, the y value is 0.00000 like this. So but it's not going ever be 0. Okay, so you can explain this. And for L part, if a is any non-zero base, explain how to write each of the following in rational form. Okay, so yeah, we know a to the power 0 is 1. Anything power 0 is always 1. Okay, and a to the power -1 is 1 over a. Okay, and a to the power -2 is 1 over a square, and a to the power -n is 1 over a to the power n. Okay, so these are going to be your solution of this L part. Now in the relation y is equals to x square and y is equals to 2 to the power x, are the y values ever negative? Explain. No, y values for these both of these relations are never going to be negative, because why? If we substitute the values of x negative, like -2, but here we have the square of this negative, so which makes always y positive. Okay, as well as for y equals to 2x also, if we substitute x value in negative, we got y value is always positive. Okay, so these are the solutions, and these are some important points that for y is equal to 2 to the power x, 3 to the power x and 5 to the power x, they are never gonna met at x-axis. Okay, they are always towards or approaches to 0, or approaches to 0, but never met at x-axis. It means there are not any x-intercept for these graphs for 2x, 3x, 5x. Okay, I don't think there are more questions that is going to be in your unit test about y equals to 2 to the power x, but the questions that you encounter in your unit test are from these parts 3, 4, 5, 6. These are the questions that you are going to met at your unit test. Okay, so we will do these questions on our next class.